yesterday, we discovered that when we had our chips and hung on to one, we got different results. And at the end of class, we decided one of those things was an independent event and another one was a dependent event. And we put these words in our vocabulary after we took the quiz. So we're talking about compound events when more than one thing happens. We spin a spinner and then we flip a coin. Or we draw a card and then we draw another card. Yesterday we drew a chip. One time we put it back and then we drew another chip. Is that independent or dependent? Does the outcome of one affect the other when we put it back? Why is it independent? You're right. Good, and so there's the same number both times. I have 2 reds and 2 yellows. I always have 2 reds and 2 yellows. The chance, the probability stays the same. So when we put it back, that was an independent event. What about when I hung on to one? Independent or dependent? Dependent. Why dependent? Why, Mackenzie? Yes, when I'm hanging on to one, instead of now having the same, like the last time, I only have 3 choices. That changes things. And so what happens is, if I were to draw a tree diagram, it would be different. When I keep it in the, or when I put it back, my tree diagram, which you do not have to draw, would look like this. On my first draw, I have a red, or a yellow, or a yellow. And then each one of those has 4 choices, right? I have red, red, yellow, yellow, red, red, yellow, yellow, red, red, yellow, yellow, red, red, yellow, yellow. And so there's 1, 2, 3, 4 ways to get a red and then a yellow out of 4, 8, 12, 16 ways, or a 25% chance. When I put it back, that one is independent because the probability for the second draw is exactly the same. Everything is the same both ways. That picture makes sense to me, Mrs. Smith. You don't have to do it, but that picture makes sense to me. You with me so far? The first draw, I have 1, 2, 3, 4 choices. It's independent when I put it back, and here's why. There were 4 choices, red, red, yellow, yellow the first time. What are my choices the second time? Red, red, yellow, yellow. They're identical. And so because the probability is the same and my choices are the same, it's independent. When I keep one of the chips, it is dependent, and let's look at why. Again, on my first choice, I have, and I'm going to spread them out a little bit more, I have red, red, yellow, yellow. But if I got a red, what are my choices next? If I have one of the red ones in my hand, on my second draw, what are my choices? Red, yellow, yellow. I only have one of those reds. That has changed. It's different, and that's why it's dependent. What if, and so it's the same here, right? Red, yellow, yellow. What if I drew a yellow one first? What are my choices then? Now I have a yellow one in my hand. Good. Red, red, because there are 2 of them, and a yellow. Red, red, and a yellow. Why is this a dependent event? Why, Rachel? Good. The second choice depends on what I took out first. So because of that, it's dependent. I still have, though, 4 ways to get a red and a yellow. So the probability of getting a red and then a yellow, I still have 4 of them, but how many total outcomes are there? How many total choices are there? Now there's not 16, there's only what? Only 12, which changes it, because now it's 1/3 and 33% and a third, okay? What happens is, my probability of getting a red and then a yellow when I hang on to it actually goes up by quite a bit. This is a dependent event. And today, what we don't want to do is keep drawing tree diagrams, right? Because it takes forever. It takes forever, yes? And so what we can do, though, is because we know there's 3 here and 4 here, we can use what we know. If I had 4 choices to start and 3 choices next, we know there's going to be 12 total outcomes. If there are 4 to start and 4 more, there are 16 total outcomes. We're going to use that fundamental counting principle one more time.